Section 7.4, Properties of Special Parallelograms. Okay, so our objective for this lesson is to use properties of special parallelograms. So everything we're going to be talking today is first and foremost a parallelogram. They're just a special type of parallelogram. We're going to use these properties of diagonals of special parallelograms and then use coordinate geometry to identify special types of parallelograms. So first of all, today are three new big words: rhombus, rectangle, and square. We're familiar with all of these words, but we're going to give them a slightly new definition today. Okay? So first, a rhombus. If I have a parallelogram, again, first and foremost, this is a parallelogram, so all of my previous parallelogram rules apply. All my previous parallelogram theorems, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other, all of our previous theorems apply. But if I have a parallelogram with, four congruent sides, so if I have a parallelogram, and if you notice here we have four congruent sides, we have a notch, 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 notch. If I have a parallelogram where all four sides are congruent, we call that parallelogram a rhombus. Okay? So if all four sides are congruent, we call it a rhombus. Okay? If I have a parallelogram with four right angles, so again, this is still a parallelogram. Opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary. Again, all of those same parallelogram theorems apply. But if I have a parallelogram with four right angles, we call that parallelogram a rectangle. Hence, rectangle, okay? Rect, straight or perpendicular, angle, angle. So if it has four 90-degree angles, we call it a rectangle. Okay? If I have a parallelogram with both, parallelogram with four congruent sides, we'll use the congruent symbol, and four right angles, we call it a square. So if it has both four congruent sides and four right angles, then we call it a square. So a square could also be called a rectangle, because all you need to be a rectangle is four right angles. Well, a square has four right angles, so I could call it a rectangle. Well, to be called a rhombus, you need four congruent sides. Well, a square has four congruent sides, so I could also call a square a rhombus. So this figure right here, this figure is a parallelogram. It is a parallelogram. Oh, first and foremost, it's a quadrilateral. Oh, sorry for the wiggles. It's a quadrilateral because it has four. It's a polygon. Quadrilateral. It's a polygon with four sides. Since it has four sides, it's quadrilateral. Since the opposite sides are parallel, it's a parallelogram. Since all four sides are congruent, it's a rhombus. And since all four angles are right angles, it's a rectangle. And since it is both a rhombus and a rectangle, we can also call it a square. Okay? So all of these words fit this figure right here. The most specific, though, the one that tells us the most about it is the word square. Because it tells me, just by me calling it a square, I know that it has four right angles, four congruent sides. It's the most specific. Now, if I was just to call it a parallelogram, I wouldn't know any of those things. All I would know is opposite sides are parallel, and then all my parallelogram theorems, okay? But we wouldn't know specifically that all four sides are congruent and all four angles are right angles if it wasn't for the word square, okay? So what I have down here is a graphic organizer a bit. I want you to think of this big black box as the box. This is a big black box that contains all of our four-sided figures. So inside this big black box is all of our quadrilaterals. The only thing you need to be in this box is you need to have a polygon with four sides. Oh, four-sided polygon, P-O. You just need to be a four-sided polygon. Okay. So the only thing you need to be inside this big black box is to be a four-sided polygon. Okay, quadrilateral. Well, we have a more exclusive club inside of this box. We have another box inside of this box that is our parallelogram box. To be inside this box, you need opposite sides parallel. Okay, so opposite sides have to be parallel. So let's denote that on here. Opposite sides have to be parallel. So let's put our arrows on this blue box. So inside this blue box is opposite sides parallel. So out here I would have the weird four-sided figures that don't have opposite sides parallel. So our weird four-sided figures, okay, that don't have opposite sides parallel. Okay, so in here I have my opposite sides parallel. So this is my parallelogram box. Okay. Okay, we have a more exclusive box inside my parallelogram box that contains those with four congruent sides. So that's here in our, oh, I'm having a hard time spelling today, guys, sorry. That is our rhombus box. That's if all four sides are congruent. We go inside this box. So that's our rhombus box. So again, that's if all four of their sides are congruent. They're inside this green rhombus box. Okay. If all four of their angles are 90 degrees, then they're inside this other box here, which is our rectangle box. So that's if all four angles are 90 degrees. Okay. They're inside this rectangle box. And then there's those very special quadrilaterals that are both in the rhombus box and the rectangle box, and those are our squares. Those have both four congruent sides and four 90-degree angles. Okay. So you can tell here that this little group of squares are inside of the rhombus, they're inside of the rectangle, they're inside of the parallelogram, and they're inside of the quadrilateral. Okay. So that leads us that we again could use all of those words to describe that figure there. But again, the most specific, the one that tells us the most information about that figure is the square. All right, so now that we know the difference between a rhombus, a rectangle, and a square, we're going to go ahead and talk about some properties of them. First, we have some corollaries. First off, again, these corollaries come off of a previous theorem. Basically, these are just their definitions written in corollary form. A quadrilateral is a rhombus if and only if it has four congruent sides. So if you have a figure with four congruent sides, we can call it a rhombus. Again, it has that if and only if, which tells me this is a biconditional. Remember, biconditional statements means that we could have a quadrilateral as a rhombus as our hypothesis. Our conclusion be it has four congruent sides. Or it can go the other way around and go backwards. Okay, so it can go either way. Okay. So a quadrilateral is a rhombus if and only if it has four congruent sides. A quadrilateral has four congruent sides if and only if it is a rhombus. Okay, same with our rectangle corollary. A quadrilateral is a rectangle if and only if it has four right angles. Again, that's an if and only if statement, so it goes either way. Or if a quadrilateral is a rhombus and a I was up here. Jumped down too far. If it has four right angles, then it is a rectangle. So this can go again either way. And then we have our square corollary. A quadrilateral is a square if and only if it is a rhombus and a rectangle. It needs to be both of those things. It is a rhombus and a rectangle. So if a quadrilateral is a rhombus and a rectangle, then it is a square. Okay. So here we have for any rhombus. So that word tells me a lot. That tells me that it has four congruent sides. It also tells me it's a parallelogram. So we have rhombus QRST. So I'm just going to sketch an idea of I'd have a QRST. It's a rhombus, so I know all four sides are congruent. And therefore the opposite sides are parallel, so forth and so on. Decide whether the statement is always or sometimes true. Draw a diagram and explain your reasoning. Angle Q congruent to angle S. Q would be angle here. S congruent here. Well, those are opposite angles. Since a rhombus is also a parallelogram, opposite angles are always congruent, so this would be always. It says draw a diagram and explain your reasoning. Well, there's my diagram right there. Since why? A rhombus is a parallelogram. So opposite angles are congruent. Okay. A rhombus is a parallelogram, so opposite angles are congruent. Okay. What about angle Q and angle R? Q and R. Well, I can tell just in this picture I've drawn here it's not true. Is there any way for it to be true? Q and R side by side, they're consecutive. Okay, from our previous section we know consecutive angles are supplementary. So if they're supplementary, if they add up to 180, but they're both the same, that means that each would have to be 90. So I'd have something that looks like this, but it'd have to be, so both of these angles would have to be 90 because there's Q, there's R, T. Opposite side, all four sides are congruent because it is a rhombus, they'd give us that. And if these two angles are congruent, well, opposite angles congruent, so that tells that it's 90, that tells that means 90. Well, I've drawn a square. So this would only be sometimes if the rhombus was also a square. Meaning all four angles are right angles. Okay, that's what we mean by there with that square, because it's already a rhombus, so we know all four sides are congruent. But if all four angles are congruent, they're all 90, then it's also a square. Okay. Example 2, classify the special quadrilateral, explain your reasoning. Well, we know all four sides are congruent, so we could call it a rhombus. But now let's double check its angles to make sure it's not a square. Well, if this angle is 70, it's a parallelogram, so opposite angles are congruent, so this angle is also 70. Since it's a parallelogram, consecutive angles are supplementary, so that means this angle would have to be 110. So this one would be 110. Opposite angles are not, we don't have any right angles there, so that means it's only a rhombus, because why? All four sides are congruent. But the angles are not all right angles, are not all right angles. So that means it's not a square, it's just strictly a rhombus. Again, we could call it a quadrilateral, it is, it's got four sides. We could call it a parallelogram, it is, opposite sides are parallel. Okay. All right, so now we're going to talk about some of the diagonals, just in a rhombus. So here if I have a rhombus, if I have the diagonals in a rhombus, a parallelogram is a rhombus if and only if its diagonals are perpendicular, make 90 degrees. So if I was to draw the diagonals into this, we know the diagonals are going to bisect each other because that's what parallelograms do. But not only do they bisect each other, if I have a rhombus, they intersect at 90 degrees. This is a 90 in here. Okay. So a parallelogram is a rhombus if and only if, again, that's that biconditional. It goes both ways. So that means that if diagonals are perpendicular, then it's a parallelogram. It's a rhombus. Okay. So then we have our rhombus opposite angles theorem. Hey, a parallelogram is a rhombus. Again, it's an if and only if, so that tells me it's a biconditional. Each diagonal bisects a pair of opposite angles. So what that means, if I draw in this diagonal bisects these angles, meaning this angle congruent to this one, this angle congruent to that one. And this other diagonal does that exact same thing. If I was to draw this diagonal in, it's going to bisect, so this angle is going to be the same as this one. This angle is going to be the same as this one. Okay. It's important to notice that these two angles are not the same as these two angles. Consecutive angles are not congruent, so their bisectors are not congruent. Okay, it just means that this diagonal divides this angle up into two equal pieces, and it divides this angle up into two equal pieces. This diagonal divides this angle up into two equal pieces and this one into two equal pieces. Again, this is true only if you have a rhombus. Okay, both of these are true for rhombuses, which therefore means, aren't they also true for squares? Okay, because isn't a square a rhombus? Okay. Find the measure of the numbered angles in rhombus ABCD. ABCD. Well, we have the diagonals drawn in. We know it's a rhombus, so I know the diagonals bisect the angles, which tells me this angle here is also 61. It's also a parallelogram, because all rhombi is plural for rhombus, rhombi, or some books use rhombuses, okay, but I know opposite angles are congruent. So I know this opposite angle, this whole opposite angle, is going to be congruent to this whole opposite angle. Well, this whole opposite angle is 61 plus 61, which is 122. Tells me this whole angle is 122. But this diagonal bisects it, which means each of these is 61. So I know the measure of angle 3 is 61, the measure of angle 2 is 61. Hey, now we need to find 1 and 4. And you see how I'm drawing all over this picture? Please draw your pictures in your practice and draw on them. Use them to help you figure these out. I know, since this is a parallelogram, I know consecutive angles are supplementary. So here I can find this whole big angle. It would have to be 180 minus the 122. Since this angle is 122, this angle, ADC, would have to be 180 minus 122, which gives me 58. That's the whole big angle. Angle 4 is just a little piece in there. So, but this diagonal from our rhombus opposite angles theorem bisects it. So it's going to divide that in half. So take 58 divided by 2. So angle 4 here is 29. So now I have this triangle. I'm going to draw it off to the side here, with an angle here of 61 and angle here of 29. Now we're looking for this angle right in here, angle 1. So I have to take 180 minus 6 is 61, minus the 29, 180 minus 61 minus 29 gives me 90 degrees. Okay, which, no duh, we will use our theorem. A parallelogram is a rhombus if and only if its diagonals are perpendicular. So I knew this was going to be 90 degrees to start because the diagonals are perpendicular. So let's see, the measure of angle 1 is 90 degrees. The measure of angle 2 is 61 degrees. The measure of angle 3 is 61 degrees. And the measure of angle 4 is 29 degrees. I think we've had them all. 1, 2, 3, and 4. Okay. All right, now we have a theorem about rectangles. A parallelogram is a rectangle if and only if, again, biconditional, it goes both ways, if and only if its diagonals are congruent. A rectangle is the only type of parallelogram that has congruent diagonals. So if I draw this diagonal in, and this diagonal in, let's label these points. Let's call this A, B, C, D. The diagonal from B to D is going to be congruent as the diagonal from A to C, or CA. The diagonals are congruent. Okay. All right. Example 4. If you are building a frame for a window, the window will be installed in the opening shown. So here's my opening. The opening must be a rectangle. Given the measurements in the diagram, can you assume that it is? Explain. The only measurements they give me is that opposite sides are congruent. We know opposite sides congruent. Okay, we don't know anything about their angles, but we know the opposite sides are congruent. So that tells me that this is a parallelogram. But there is no way for me to know that it's a rectangle. Opposite sides are congruent, so it is a parallelogram, but there is no way to tell if the angles are 90 degrees. So Can you assume that it is? So no, we cannot assume that it is. There's no way to tell if the angles are 90 degrees, so we don't know if it's a rectangle. We don't know if it's a rectangle. Okay. Let's see, you measure the diagonals of the opening. So we measure the diagonals, so we're measuring, if we came in and measured this diagonal from here to here, measured that diagonal, and we measured this diagonal from here to here. The diagonals are 54.8. I kind of can't see it in there. 54.8 and 55.3. What can you conclude about the shape of the opening? Well, my diagonals are congruent, so I can conclude it is not a rectangle since the diagonals are not congruent. Okay, so this changes our thinking a little bit about rectangles. In elementary school, we tend to, oh, if I have 2 long sides and 2 short sides, hey, it's rectangle. Not necessarily. It needs those 90-degree angles for me to call it one. Okay. Okay, now we're in example 5. In rectangle, so we know it's a rectangle, QRST, QRST. Q to S, that's one diagonal, is 5x minus 31. R to T is 2x plus 11. Find the lengths of the diagonals of the rectangle. Well, we know the diagonals are congruent, so I know Q to S has to equal R to T. Q to S, 5x minus 31, equals R to T, 2x plus 11. So I know opposite sides are congruent. Let's add 31 to both sides. Gives me 42. I'm going to subtract the 2x from both sides. 2x gives me 3x equals 42. Divide both sides by 3. X then equals 42 divided by 3 is 14. Find the lengths of the diagonals. So we want to know the lengths of the diagonals. We know QS equals 5x minus 31. So let's put the 14 in there. 5 times 14 minus 31. We get 39 units long. Okay, and that would be true for the other diagonal. We can try it. R to T equals 2x plus 11. 2 times 14 plus 11. 2 times 14 plus 11, guess what, is also 39. Okay, so the diagonals are congruent. Okay. Okay, we have one more. Example 6. Decide whether ABCD with these vertices is a rectangle, a rhombus, or a square. Give all names that apply. So let's plot this point. I need the point -2, 6, 6, 8, 5, 6, 7, 8, 4, 0, and then 4, oh, -4, -2. Okay, so let's double check my points. I have the point -2, 6, 6, 8, 4, 0, -4, -2. Okay. Okay. So there's a lot of different ways to do this one. Okay. First, let's determine whether it's a rhombus or not. If it's a rhombus, then we know the diagonals are perpendicular. The angles bisect each other. We need 4 congruent sides. So let's go ahead, and I don't know if we want to do maybe some congruent sides. A, B, C, D. Okay, so we're going to have to go ahead and check to see maybe if all 4 sides are congruent. Okay, so I'm going to have to do the distance formula a lot. The distance formula, the square root of. Subtract the x's squared plus subtract the y's squared. Okay. So here we'll have to do the distance. Let's go the distance from A to B. So we're going from A to B. So I want to take the x's, -2 minus 6 squared plus, let's go 6 minus 8 squared. I'm going to do everything inside the square root in my calculator. Okay, so I'm going to take parenthesis -2 minus 6 squared plus 6 minus 8 parenthesis squared. We get 68. So a to b is the square root of 68. So now we need to try b to c and repeat. So b will have 6 minus 4 squared plus 8 minus 0 squared. Again, I'm going to do everything inside that square root in my calculator. Parentheses 6 minus 4 squared plus 8 minus 0 squared. We get 68. So far, so good. Two sides congruent. Okay, so now we need to go check c to d. Same process. From c to d, 4 minus a negative 4 squared. 0 minus a negative 2 squared. 4 minus a negative 4 squared plus 0. 68. And then, so that was c to d. Last we got d to a. Okay, so now we've got d to a, d to a. So we have negative 4 minus a negative 2 squared plus negative 2 minus a negative 6 squared. Negative 4 minus negative 2 squared plus negative 2 minus negative 6. Whole lot. Oh, wait. Nope, I did that wrong. Negative 4 minus a negative 2 squared. Negative 2 minus, that's just a positive 6. I did a negative 6. Let's get rid of that. Delete. Square root of 68. So it tells me right there it is a rhombus. All four sides are congruent. Okay. So we know it's a rhombus. Now what about a rectangle or a square? Well, I need 90-degree angles to determine rectangles or squares. One way of determining 90-degree angles is to look at the slope. So you could look at the slope. Another way you could also look is the diagonals. If the diagonals are congruent, then it's a rectangle. That was from our last theorem. The diagonals are congruent, or you could look at slope if you have negative reciprocal slopes. Okay, so we could either use the distance formula on the diagonals. I'm kind of tired of the distance formula after all of these. Or we could look at the slopes of each side. Slopes I can very easily count. This goes up 1, 2, 3, 4, 5, 6, 7, 8 over 2. Up 8 over 2. This one goes up 2, 1, 2, 3, 4, 5, 6, 7, 8. Up 2 over 8. But if you notice, they're not negative reciprocals of each other. They're just reciprocals of each other. This one goes down 1, 2, 3, 4, 5, 6, 7, 8, back to negative 8 over negative 2, which is, again, just positive 4. This one's positive 4. This one's 1/4. But they're not negative reciprocals of each other. So that tells me that since I don't have that negative reciprocal part, that they aren't perpendicular. Not perpendicular, which means that it can't be a rectangle, not a rectangle. And if it's not a rectangle, then that means it's also not a square. So the only word I can use for this is rhombus because of the opposite sides being congruent. Okay. All right, so go ahead and write your practice down here at the bottom. Again, use this vocabulary as much as you can. Make sure you're using the words appropriately, and good luck.